Where do evolutionary family trees come from? Welcome to Critical Thinking Scan, where we look at how you can think about any faith-challenging message and arrive at a biblical, logical conclusion yourself. I'm Patricia Engler, and today let's think about some assumptions behind evolutionary family trees, or phylogenies, which are hypotheses about which organisms descended from which ancestors. In my notes from an evolution class, I wrote 4 general steps to make an evolutionary family tree. Step number 1, choose which organisms you want to include. Normally, you would already assume those organisms are evolutionarily related. It's also common to include an organism you don't think is closely related as an outgroup or control condition. Step 2, choose what characteristics to compare. What similarities do you want to base your tree on? Fossil horses, for instance, are typically compared based on toe number and tooth type. Living species today are often compared using DNA or RNA sequence similarities. To decide which sequences to use, you look for orthologs, similar-looking genes you already assume were inherited from the same ancestor. Once you've identified supposedly orthologous genes, you assume that major differences between those genes must have been from DNA getting inserted or deleted after the species you're comparing split away from their common ancestor. So you ignore those differences and only compare the parts of the sequence you assume came from the original ancestor. This is called aligning the genes. Next, you trim the aligned sequences by removing any parts deemed low quality. As a 2020 paper in Nature Reviews explained, it is common to filter ambiguously aligned regions. Filtering can be based on ad hoc criteria regarding alignment quality, such as gappiness and sequence similarity, or by retaining only the alignment positions that are robust to changes in alignment parameters. In other words, you get rid of remaining differences you don't think should be included. Once your data is ready, step number 3 is choosing which method you want to analyze it with. For instance, do you assume the most closely related organisms have the fewer genetic differences overall, or the fewest evolutionary steps between them? Or do you go by statistical likelihood of different evolutionary relationships given your data? Finally, in step 4, you pick the resulting evolutionary tree which best fits your data, typically by using a computer program. Now, already, you can see why my evolution professor emphasized that evolutionary family trees represent hypotheses and not definite facts, because they are interpretations from historical science based on many layers of evolutionary assumptions. As one evolutionary researcher wrote, "Molecular systematics of every provenance, in other words, all the methods of analyzing evolutionary family trees, make biological and/or methodological assumptions about the nature of the evolutionary process. These assumptions affect which tree you end up with, assuming the type of evolution you're trying to reconstruct is even possible. For example, it's not uncommon for trees based on physical similarities to tell a different story from trees based on DNA similarities. That's why entire groupings of supposedly related species had to be redefined after DNA sequencing became possible. But even different genes commonly tell different evolutionary stories, as a New Scientist article from 2009 entitled "Why Darwin Was Wrong About the Tree of Life" observed. The article pointed out that different evolutionary trees based on RNA versus DNA don't always match each other either. People hoped that comparing large samples of many genes would help clear up which evolutionary trees were most likely correct. But, like a paper from 2017 explained, it has become clear that analyses of these large genomic data sets can also result in conflicting estimates of phylogeny. This study found different evolutionary trees resulted from looking at many coding DNA sequences versus many non-coding DNA sequences. The conflicting stories from different trees gets even worse the farther back you go along the supposed evolutionary timeline. As one evolutionary paper observed, for ancient clades, phylogenetic analysis of modern systematic datasets, that's many genes and many taxa, has taken 2 paths given currently available methods. Each approach includes assumptions that are violated by empirical systematic data. It added that even when comparing longer DNA sequences, wholesale conflicts among gene trees were apparent. I could go on, but that's a sample of the issues with evolutionary family trees and the assumptions that go into them. to remember next time you see an evolutionary family tree presented as fact in a textbook. For more on how to think critically about faith-challenging messages, you can access my other CT Scan episodes packed with tactics, tips, and tools that helped me as a Christian student at secular university. Thank you for watching. Hey, it's Patricia here. Just wanting to let you know that if you like these videos, a free, easy way to help Answers in Genesis Canada create more content and equip more people to defend their faith is to hit that like button, subscribe to our channel, click the bell, and of course, share these resources. That lets the social media algorithms help these videos reach more people who can benefit from them, saving us advertising expenses while promoting biblical authority. Thank you so much.